watch this component warp and deform. Often, injection molded parts look perfectly aligned right off the line, only to suffer from warpage, shrinkage imbalance, and sink marks later on during storage or real-world use. To prevent those delayed failures, you need to know exactly how to achieve dimensional stability in injection molded parts. This checklist outlines a 4-step diagnostic framework. We designed it to handle modern manufacturing pressures, like the push for thinner walls, complex geometries, and higher ratios of recycled content.
OnlyTRAININGS. Learn what works in the industry.
Step 1 is where we begin. By adopting this step-by-step approach, your facility can move away from reactive trial and error and start producing components with predictable precision. Step 1 requires you to critically evaluate your current material formulation and baseline polymer selection. A polymer's inherent crystallinity and its moisture behavior establish its baseline dimensional stability before a single pellet ever enters the mold. This split-screen diagram illustrates that baseline. On the left is a standard unfilled polymer matrix deforming under load. On the right, you see a tightly locked, glass-filled polymer matrix. The strategic use of those reinforcements distributes the stress and prevents post-mold distortion. If your material matrix is inherently unstable or mismatched for its environment, even the most perfectly engineered mold cannot compensate for it. Next is step 2. You must audit your current mold conditions and tooling geometries. As production targets shift toward lightweighting and faster cycle times, the margin for error within your tooling drops to near zero. This thermal heat map shows a part cooling unevenly inside a mold. Hotter sections contract differently, causing structural bowing. To prevent this, implement precise cooling channels. With balanced lines established, the part reaches thermal equilibrium and ejects perfectly straight. Achieving that thermal balance within the tool provides the physical mechanism required to lock in the dimensions established by your material formulation. In step 3, we look at the machine inputs, guiding you to audit your line settings and the ratios of virgin to recycled materials. Introducing recycled content or aggressively pursuing lightweighting targets requires specific shifts in your processing parameters directly on the factory floor. Because variable material inputs behave unpredictably, achieving stability requires adaptive industrial insight to adjust to those shifts, rather than a rigid adherence to textbook theory. When material inputs fluctuate, static processing parameters will fail. Dynamic optimization is the only way to maintain a consistent yield. Successfully executing those first 3 steps requires access to specific industrial data, precise parameters, and expert guidance.
OnlyTRAININGS. Learn what works in the industry.
And here's the factory floor's greatest illusion. You see it right here. Immediately after production, parts drop out of the mold, hit the conveyor belt, QA measures them, and boom. They look absolutely perfect, dimensionally acceptable. You breathe a massive sigh of relief. But then, you look at the reality in the field. Hours, days, or maybe weeks later during real-world use, maybe they're sitting in a sweltering warehouse, getting transported, or they finally hit the secondary assembly line, and disaster strikes. We're talking warpage, shrinkage imbalances, sink marks. Suddenly, your precision component looks more like a piece of modern art, and parts that passed inspection with flying colors, yeah, they no longer fit together. It's a massive headache that leads straight to assembly failures, scrapped batches, and delayed shipments. Fundamental rules of the game have completely changed. Those basic troubleshooting guides and traditional quick fixes that worked, say, 10 or 15 years ago, they just aren't cutting it anymore. Why? Because the margins for error have practically vanished. First off, lightweighting requirements and thinner walls. We're constantly trying to do way more with a lot less material, which literally means there's less physical structure to resist internal stresses. Then you throw in complex geometries and the endless push for higher aesthetics. On top of all that, everybody wants faster cycle times. We are pushing plastics to cool and set at absolute breakneck speeds. And perhaps the biggest wildcard of them all, higher recycled content. Integrating regrind and recycled materials introduces just tremendous variability in how the material flows and shrinks. Combine all of this with really demanding high thermal end-use environments, and honestly, you've got a perfect storm for part distortion. Which brings us to this crucial reality. Reliable dimensional stability is no longer just a tooling challenge. You simply can't just tweak the mold and expect all your warpage problems to magically vanish. Relying solely on traditional tooling adjustments, That's a trap. Today, achieving true stability requires understanding an incredibly complex interplay of variables. You're dealing with how specific polymers behave, how fillers and reinforcements actually orient themselves, the impact of moisture, the rate of crystallinity, and exactly how your cooling balance interacts with your processing parameters. It's not just one thing. It's a holistic, multidisciplinary challenge. So what exactly is the ultimate practical rescue plan for these modern manufacturing headaches? Well, it's a highly focused, technical session built from active industry professionals, not academics or generalists. And that is the core advantage here. This training is shaped by people who have sat at the exact same workbenches as you. They faced the exact same devastating scale-up failures. They've dealt with the same frustrating regulatory and production pressures. They aren't just up there teaching theory, they're teaching survival and success on the modern production floor. Now, why is that distinction so vital? Think about it. Decade-old academic textbooks are great for learning the very basic fundamentals of polymer science, but let's be real, you already know the fundamentals. When your production line suddenly goes down because a glass-filled nylon part is warping way out of tolerance, some textbook from 2012 isn't going to help you. You need insights embedded in real-time industry practice. You need strategies from professionals who are tracking emerging technologies, shifting regulations, and evolving application challenges right now, today. Basically, you need insights you can actually apply tomorrow morning to fix a scale-up failure. You might be wondering, okay, is this actually technical enough for me? Well, this is built specifically for injection molding professionals, process and tooling engineers, polymer formulators, QA and quality control teams, and product development and R&D. So whether you're an automotive plastics professional or a packaging manufacturer, if your daily challenge involves managing shrinkage variation and making sure parts actually fit together out in the real world, this technical session is tailor-made for you. It assumes you already know the basics and just pushes you further.
OnlyTRAININGS. Learn what works in the industry.
Establish the problem is complex, but OnlyTRAININGS has made removing these massive manufacturing roadblocks incredibly accessible. Boom, $99. Just let that number sink in for a second. For a one-time payment of $99, you are getting an expert-led industrial masterclass. I mean, when you think about the staggering cost of a single scrapped batch of molded parts, or the cost of a machine just sitting idle while engineers argue over cooling rates, a $99 investment to gain real actionable solutions is, quite frankly, an absolute no-brainer. And look at the immense value of what that enrollment actually includes. You aren't just getting a video to watch once and forget about. You get full access to the complete training for a solid 3 months. You get a subject-specific training certificate to actually demonstrate your advanced capabilities. You can fully download the training materials. We're talking presentation slides, Q&A, and FAQ PDFs to keep on your local drive forever. But here is the absolute game changer. The 24/7 Expert Connect Forum. If you have a specific, incredibly stubborn technical doubt about a part you're running right now, you can connect directly with the expert via the discussion forum to get it clarified. You're essentially getting a consultant in your back pocket.